All right, so hopefully everyone has worksheet 9, but what I'm going to ask you guys to do today is go ahead and start on the warm-up here, and you're just going to complete the table of the inverse function, and then I'm going to ask you to graph the function and its inverse on the grid. And then for problems 3 and 4, see if you can write an equation for each of them. So give yourself a few minutes to work on that warm-up. I'll fill it out as well. See my screen? All right, so for the warm-up today, you're just going to be flipping the table. So switching the x and y values on the table, that's really important. And then you'll also end up sketching the asymptotes. I sketched one of them in green, and I said the asymptote's in green for the first function that I did in black ink. And then for the other function, the asymptote is in blue, and that was just because the second function I did in red ink. All right, but I just wanted to make sure you clarified the asymptotes because it could look a little weird with both graphs being drawn on here. Seeing a green line and then the red line going through the green asymptote. That's because the green line is not an asymptote for the red function. Its only asymptote is the blue line. So really important to keep that in mind there. But we should be able, with these exponential functions, we should have some type of asymptote when we're doing these problems. One thing that'll help us identify the equation, it's going to be these couple points right here, which we talked about yesterday. You got this point 0, 1, and then this other point that's 1, 2. And we might remember if we created XY tables, one of the things that we looked at yesterday was these equations will have the point 0, 1, that kind of shows where it's going through the axis or its intercept. And then 1, b. So in this case, b equals 2, and that's how we would write this equation. We can say y equals 2 to the x. Okay, that's how we know this is an exponential equation. We can kind of see it growing that way. And then we know the b value is going to be wherever that 1, 2 is. That's how we would do this problem here. Now, the last part, problem 4, if I were trying to write the equation of the inverse, we would start with y equals 2 to the x, and then we would swap, and we would get x equals 2 to the y. Now, to get rid of an exponent, what we've done in the past is we could say, oh, we're going to take like the y root of both sides. But the problem is we're trying to solve for y, and now we've got y inside of a square root. With anything, that makes this look more complicated. So we don't really have that method yet, and that's what we're going to be talking about today, is how do we find this equation. That's the whole purpose of the lesson today, is starting to look into what is the inverse of an exponential look like, and how do we do it. All right. One more thing I wanted to mention before we move on is just about these asymptotes. What we do with an inverse is we flip the x and y values. All right. We also flip the domain and range. And the last thing we flip is the asymptotes. Or we should say swap, I guess. That's the word I was using. Asymptote swap, just like all other x and y values. That's important to note here. So the asymptotes will swap just like everything else. So the asymptote was y equals 0, and the asymptote of the inverse function is going to be x equals 0. The same thing would happen if the asymptote was y equals 3. The inverse asymptote would be x equals 3. So we can find asymptotes with that same exact inverse method. That's always going to be true. Okay, are there any questions before we move on to the worksheet today? No? Okay. My worksheet's a little blurry. We're going to see if we can get it fixed here. I did talk about this a little bit yesterday, but now we're starting Mod 2, and this is going to be like one of the most difficult modules we cover in the entire school year. Mod 1, if you thought that was pretty straightforward, pretty easy, or even if it was a little tricky for you, I can tell you this one's going to be really tough. Just because these logarithms, this is a new thing for a lot of you guys. Probably haven't seen logarithms before, and mean, the last time you learned an entirely brand new math concept, it's probably been like since like 7th grade. In reality, like a lot of things you've learned have been like existing concepts that you've known about, and then you just dug deeper into them. So logarithms might be the first really new concept in a long time. So just something to be warned about before we start talking about it today. This module is going to be a couple weeks long, and it can be tricky. So make sure you take advantage of office hours. You're staying in communication with me if you're struggling on the concepts a little bit, just to keep that in mind. Okay, but let's start talking about these things called logarithms today. And we can start by talking about, we know that, like, for example, 2 squared equals 4. 2 to the 3rd power, 2 times 2 times 2 equals 8. But sometimes we're going to have values where it won't work out. We're going to say, like, well, 2 to the x power equals 6. Well, I know x is going to be somewhere between 2 and 3, but I don't really know what number it's going to be. Because when x is 2, this answer is 4, and when x is 3, this answer is 8. So this is where logarithms come from. Logarithms are used to rewrite the equation, and that's exactly what happens here. We rewrite it as this log base 2 of 6 equals x. And then we're solving for exponents. That's exactly what the purpose of logarithms. So let's go and write the general logarithmic function here. It's just the word log, and then base b of y equals x. And the expression right below that I have log base b of y is read aloud as log base b of y. So whenever you're reading it out loud, you would say the word base, log base b of y. And this is logarithmic form if and only if our exponential form looks like this, b to the x equals y. Okay, so we always want to write it down as b to the x equals y, and then we can convert it to logarithmic form. Okay, easy way to remember it. So first thing I want to focus on here is the b value. The b is the base of the exponents and the base of the logarithm. So the base of the exponent, when we're switching forms, base of the exponent, I'm going to say goes to the basement of the logarithm. Okay, so base of the exponent becomes base of the logarithm, or basement to basement. All right, base becomes the base. So whenever you're switching forms, that's where the b value is going to end up. All right, the other thing that's going to happen when we're switching forms, the x is going to go to the other side of the equal sign. And that happens because logarithms solve for exponents. All right, solve for exponents. That's always the case. So whenever we see something in logarithmic form, what are we solving for? An exponent. All right, I'll say that a lot this module, but we are always solving for exponents. That's the purpose of logarithms. That's why they were invented. Exponent, exponent. So that's where they go. And then the last one, the y value, is what's left over. All right, so we can just ask yourself kind of like, what's left over? What have we not touched yet? The y value. And the y moves to the left side of the equation next to the logarithm. Okay, log base b of y equals x. That's how we can convert between the two forms. All right, I'll show you an algebraic method to do it as well, but not today. Today we're just going to say this is the conversion formula. All right, something useful to memorize. If you're more of an algebraic thinker, then I can show you how to do that algebraically later. And this first example shows us, we're just going to look at a few examples of how to convert the forms. But we see the b value there. We can see the exponents. There's the 3 and the 3. And then we see what's left over, the 8 and the 8. That's how they switch forms. For the second problem here, log base 4 of 1 equals 0. We are going to write base 4, and then the exponent was 0, because that was what was on the other side of the equal sign, equals 1. And one thing to do whenever we're converting from logarithmic form to exponential form, we should be able to check it and say, does this make sense? Like, does 4 to the 0 power actually equal 1? And yes, we talked about that last class, we talked about that on Tuesday, I should say. Anytime you raise something to the 0 power, it does equal 1. So that checks out. Okay. Going the other direction now. Oops, we've got this base 12. Well, it's going to have to be a base 12. I'm going to do this real quick. There's the base. So that becomes our 12. And then we have this other 12 that's left over and solves for the exponent, which is 1. So exponent, that's our 1. That's what we're solving for. I have this 12 that's left over, and then the base of 12. That's how we convert between these two. Something else I really want to note here. What happens when we have log base 12 of 12? What does it equal? It equals 1. Guess what happens if we had something like log base 6 of 6? Do you know what it would equal? 1. Log base 729 of 729. It's going to equal 1. So in general, log base b of b will always equal 1. That's kind of a good rule of thumb. It's a good one to recognize. That's always going to be true. Another one that's always going to be true is actually right here, because we have log base 4 of 1 equals 0. Log base 7 of 1 will also equal 0. Log base 12 of 1 will equal 0. So in general, log base b of 1 is going to equal 0. That's also going to be true. Whatever the base is, as long as it's of 1, that's always going to equal 0. So those are some good logarithms to recognize in general. We'll always see those patterns. All right. A couple more examples here. I'm just going to bust them out real quick. You could have a log with a fraction base. That's perfectly fine. And that just becomes the base of our exponent. And we get 1/4 to the negative 1 power equals 4. And that makes sense because whenever we have a negative power, you flip the fraction over. So 1/4 becomes 4 over 1 to the positive 1 power. Okay, this is where those properties of exponents that we covered on Tuesday come in handy to know. All right, again, we don't need to know the names of them. We just need to know how they work. All right, another quick example here. If we have some variables in there, I have log base 2 of x squared equals x. So technically, this is going to be base 2 to the x power equals x squared. That's how this one would look. So even if it gets a little confusing there with this stuff, we're just going to carry this quantity in the parentheses to the other side of the equation.
Mr. Street?
Yes, question.
So, I guess...
Okay. And then our last example here was 15 to the x power equals 225. Let's go ahead and copy this one down. So this is going to be log base 15 of 225 equals x. And that's the perfect example of why we're doing this. We're trying to solve for x. So you got to get x by itself on one side of the equation. And this is the method where we would be able to pull that off. Okay, I've got 8 problems here. I want you guys to work on those independently right now. Okay, so rewrite each equation in exponential form. Okay, that's the first 4. And then the next 4, rewrite them in logarithmic form. So take a minute. Okay, so go ahead and check your answers on these 8. Hopefully you guys had enough time to look at all of them. I went ahead and put them up here. For the first 4, again, those are 4 that you should be able to easily double check, like 3 to the 4th power, 3 times 3 times 3 times 3. Does that equal 81? Yes. And you can verify. I put that in the correct order. Because if you had like 3 to the 81st power equals 4, that doesn't make sense. So that's what I mean by make sure you're double checking your answers and that they make sense to you. Like number 2, if you had 7 to the 7th power equals 1, that's not right. But 7 to the 1st power does equal 7. So that's a good way to double check your answers here. Okay, and problem number 4 here, I really like this one just because you can kind of look at it and you can see I have a negative 5th power here. So the first thing I want to do is get rid of that negative. I'm going to flip the fraction over. So 1/2 to the negative 5th power is the exact same thing as 2 to the positive 5th power. And 2 to the positive 5th power equals 32. 2 times itself 5 times. So that's a good way to see it using the negative numbers as well. Okay, and then problems 5 through 8, we're trying to put logarithms in the opposite order. And hopefully we start recognizing things like log base 3 of 9. There's a relationship between 3 and 9. 3 squared is 9. So that would make sense. That's what's happening here with problem 5. Any questions on these 8 before we move on? Or any questions about this first page in general? Okay, let's go ahead and move on then. We're gonna scroll here. I gotta scroll to the new page to hopefully get it into focus. There we go. I don't know why it's doing that for me, but it is. All right, the next part, just evaluating logarithms. And that's where we have a strategy where we can just kind of do guessing and checking to figure out what the logarithms are. And I think the best way to evaluate these is to go ahead and change the forms. So for example, this first one, log base 4 of 64, that can be rewritten as 4 to the question mark equals 64. And now we have to ask ourselves, what power of 4 gives us 64? So for example, 4 to the 1st power equals 4. 4 squared equals 16. 4 to the 3rd power equals 64. So there it is, it's 3. So the 3rd power of 4 gives us 64. That's kind of the idea with these particular problems. Rewrite them in exponential form and then kind of think it through. The second one can be rewritten as 5 to the x, or 5 to the question mark, equals 0.2. And honestly, I think it's really hard to see these things with decimals. I think what will make it a little bit easier for us than a decimal is to rewrite it as a fraction. Because if I rewrite 0.2 as a fraction, and you have a fraction button on your calculator that you could use, that can make it easy for you if you're not sure how to turn that into a fraction. And it's actually 5 to the question mark equals 1/5. And think about what type of exponent do you need to turn an integer into a fraction? You need a negative exponent. So our answer is going to be negative something. And then think about if you just make it a -1, that's going to take 5 and make it a positive 1. That's going to make it a 1/5 to the first power. So this would be -1 as our exponent. That's kind of what's going on with that second one there. Okay. Yeah, instead of writing a question mark, you could write an X if you wanted to instead. That's perfectly fine. And then the last one was log base 36 of 6. This is the third type of example we're going to look at with a type of exponent we could potentially have. This is 36 to the question mark equals 6. So now 36 and 6, they have some type of relationship. If I just gave you 36 and said, how do you get this to 6? What would you think of? There's some other mathematical operation we could use. Anyone know what it is?
Square root.
A square root, exactly. I could square root 36 and get to 6. Well, did you also know that you could rewrite square root as an exponent? Square root of 36 is the same as 36 to the 1/2 power. That's how we write square roots as exponents. So 36 to the 1/2 power would be 6. And you can do this with more than just a square root. Like if I said square root of 36, you don't have to write the 2 technically. I could write this as, I'll write it as a different root though. We'll say third root or something. So you could write it as the third root of 36. That would be 36 to the 1/3 power. The fourth root of 36, 36 to the 1/4 power, etc., etc. So the only root that's not written with a number in there is the square root, but it's called the square root. This is the cube root. This is the quartic root, but we just call them third root, fourth root. That's perfectly fine too. But we can rewrite any one of those in exponential form. So I guess what my point is here with evaluating logarithms, we could have an answer that has a negative exponent, or we could have an answer that has a fraction for an exponent. Okay, your turn. I want you to try evaluating problems 9 through 12. Take a little time to work on these 4 problems. All right, give it a try. Okay, let's take a look at these 4 problems then. The first one, 2 to the question mark equals 32. So I think about it like 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. Perfect. So this one would just be 5. That's what we would evaluate this one at. Same with 4 to the question mark. 4 squared is 16. 4 to the third is 64. 4 to the fourth is 256. Now let's put that in red. All right. And then number 11, this is where it gets a little tricky. I'm going to zoom in on that for us. So it's 4 to the question mark equals 8. So let's go ahead and clear that off a little bit there. So what we want to do with this one is we got to ask ourselves, in order to get to 8, I know that 4 to the first is 4. 4 squared is 16. So our exponent is going to be between what 2 numbers? 1 and 2. Okay, because it's got to be somewhere between there. We don't know where exactly between there. But what we could do is technically we could say, what's 4 to the 1/2? Like if we square rooted 4, we're going to get 2. All right. And then likewise, if we took 2 and raised it to the 3rd power, we're going to get 8. So what we're really doing here to bridge this gap is we're going to take 4, we're going to take it to the 1/2 power, and then we're going to raise that answer to the 3rd power. So we're doing the 1/2 times 3. 1/2 times 3 is 3/2. So the answer for this one is actually 3/2. That's how we get that value there. So again, it's just kind of a weird way to think about it, but that's what we're doing. Is we're doing like 2 different operations here. We're saying first we're going to square root it, and then we're going to cube it, and we're going to get to 3/2. That one's a really tricky one. So if you got that one, awesome. Pat yourself on the back. If you didn't, not a big deal right now. We're going to work more on those types of problems. All right, and last problem here. Come on, zoom out a little bit. There we go. 1/5 to the question mark equals 125. So the absolute first thing I see there, I can rewrite this as 5 to the negative power. If I make it a negative number, I'm going to be able to swap it and get it to 125. So make it a negative power. Second one, 5 to the first is 5, 5 to the second is 25, 5 to the third is 125. So this one equals -3. That's how I would get the -3 here. So it'd be 5 to the third or 1/5 to the negative third would get us to 125. That's kind of how we'd work through this particular problem to kind of guess and check for it. Okay, those guess and check problems are a little tricky. All right, now I'm going to send you guys to breakout rooms here in a second. But the first thing I'm going to do is I'm going to show you what I want you to do with these number lines here. I'm not going to ask you to solve these ones or evaluate them for exact answers, but we're going to try and do our best here. We're going to see where these ones land on the number line. And the way we do that is we start with like log base 3 of 3, which I already told you if you see 3 of 3, that's going to be a 1. This is the same number twice. Another way to think about it is 3 to the question mark equals 3. So it's 1. So that's where I want you to put the A, is right above the 1 on the number line. All right. And then we would do the same thing here. 3 to the question mark equals 9. Well, it's going to be 3 squared equals 9. So B goes at number 2. The third one, 3 to the question mark equals 1/3. Well, to get it from an integer to a fraction, we're going to need to flip it. So -1 would be part C. Part D, if you see anything base 1 or base 3 of 1, base of any number of 1 is going to be 0. Or we could actually flip it, 3 to the question mark equals 1, and we can see it that way. It's got to be a 0, 3 to the 0 power equals 1. And then the last one, part E, 3 to the question mark equals 1/9. This one, you can say I'm going to flip it, so it's got to be a negative number, is 1/3. And then when I have 1/3, I square the 1, I get a 1, I square the 3, and I get a 9, so that's how I get to 1/9. I went through that kind of fast, but that's what we're doing for these 5 numbers here. Something else to keep in mind, we might have one that says something like, let's say log base 3 of 6. So on some of these number lines, you might see something like that where it's 3 to the question mark equals 6. So you gotta ask yourself, okay, 3 to the first equals 3. 3 to the second equals 9. So 3 to the question mark is going to be somewhere between 1 and 2. So if this was like problem F, I would say I got to put problem F somewhere over here. I don't know where, but I'm going to put F somewhere between 1 and 2. That's what I'm asking you to do. I'm not asking you to find the actual number if it's between 2 net values, but I'm just asking you to go and put it on the number line where it should be. And that'll happen on some of these problems as well. Okay, you don't need to find the exact number, but you do need to figure out the location of it. All right, I'm going to send you guys into breakout rooms to work on the rest of these. There are a few of them. So work with your groups. Don't just sit there and hope that the answers come to you. If you don't know how to do it, I'm going to send you to breakout rooms now. Work together, figure it out, work on these other problems. I'll bring us back in about 10 minutes. Thank you. All right, so we'll check our answers on these. Are there any questions on any of these as we're going through these problems? Check your answers on 14 and 15. Oops, zoomed in a little bit there. Problem 16 and 17. I'll scroll up to these ones. So 17 is the first one where we saw a number that wasn't quite fitting in between or exactly on an integer value, because we end up with 8 to the question mark equals 16. And we know 8 to the first power equals 8. We also know 8 to the second power equals 64. So that's how I chose my location for C. I know it's between 1 and 2 because those are my exponents. It's between 1 and 2. But I also think it's closer to 1 because 8 squared is 64. 8 to the first is 8. So it feels like it's going to be a lot closer to 1. That's why I chose to put it a little bit closer to 1 than like right in the middle or something like that. Okay. Any other questions on these as we move through them? 18, 19, 20. Any questions at all on these ones? No, we're feeling okay? All right, great. Last thing to talk about today then. Special logarithms. Last topic of the day. So special logarithms are what we see in our calculator. These are what we'll see the most often. There's one that's called a common logarithm, which is a logarithm with base, not e, it's going to be base 10. All right, and it's denoted, it would say like log base 10, or we might just simply just see the log number, but there's no number written next to it. Sorry, I'm seeing here. Oh, okay, so we did want to see one. We want to see numbers 17 part C. Did I explain that well enough, or did we need to see more about it for 17 part C? Sorry, I'm just seeing the comments now. So did this make sense when I talked about 17 here, where we look at 8 to the first power, 8 to the second power, so we know our question mark's going to be between 1 and 2. And that's where we decided to put C, was based on that. Okay. Anyway, sorry about that. Back to this. There's the common logarithm. There's another one called the natural logarithm, and that is base E. That would be log base E, or it's going to be ln. It's written as like a capital lowercase l and a lowercase n, but I'm writing as a capital L here just so you can see it. But that stands for natural logarithm. Logarithms were not invented by someone that spoke English, so that's why it looks like ln and not nl for natural log. But those are the buttons that are be on your calculator. There is a log button over here and a natural log button, and that log button is base 10 and the natural log button is base E. Okay, so that is true for your calculator. So the common logarithm, written as log base 10 of x, or it would just be log of x. So you just won't see any base written next to it. That's typical of all common logarithms. The natural logarithm, you'll never see it written as log base E at any time. You'll always see it written as ln of x. But when you see that, you have to recognize like, oh, that's base E. Okay, and E is just a number. We haven't really talked about the number E too much yet, but it's a number for exponential growth that we do deal with. We'll deal with it more in IB math, but we might see it in this class as well, a little bit. And basically your calculator is going to take these problems, like log of 6 equals x, and it's going to think about the exact same thing we do, the guess and check method, where your calculator is like, okay, x has to be a number between 1 and 2, and then your calculator is going to figure out exactly what number that is. That's how your calculator works to evaluate these logarithms. Okay. The last 4 examples here, just basically practice putting them in your calculator and then round to the nearest hundredth. Nearest hundredth would be 2 decimal places, so the 0.00. All right, so I want you to take these 4 problems, and if you've got a calculator with logarithms on it, I want you to use it right now and just practice putting these in. You should get just whatever the number is, round to the nearest hundredth.
To the power of, and then.
Okay, yeah, you have to delete the power of, or you could just put the power of 1 in there, which is perfectly fine. Okay, so the first one, let's look at these last 4. The first one should be 1.07. The second one, log of 1. I see that one. You might also see log base 10 of 1. That one's going to be 0. I can tell that without even putting that into a calculator. Okay, so sometimes that'll happen. Part C should be like 2.70 when we round it. And then the last one, natural log of E. Another way to think about it, we just said it's log base E, so that's log base E of E. So the answer should be 1 for that very last one. So you see the base and the number match up. So that's how we know it's going to be 1.
For number A, you gotta round it one more.
What was the answer for A? It should be log of 12. So it should be 1.079. You're absolutely right. So I should make it 1.08. Thank you. So just a rounding error on my part. All right, so 1.08. All right, that's what part A is going to look like. All right. Any questions